Hello, everyone. We are looking at the questions from our package, exercise 1, determinant phase 5. So this is question number 33. Now, if you look at the question is, we have to prove what is given about the determinant without expanding. So these questions, we don't have to expand and prove. We have to use the properties of the determinant. Now, the determinant that is given to us, if you look at the determinant, it is one of the standard determinant that we have studied. It's called circular type. So the very standard approach for such determinant is, if we look closely, the A, B, C, B, C, if you just add up all the rows or all the column, we'll get the same elements and then we can take it common. So let's start. So the first thing will be row 1 plus row 2 plus row 3. If we do this, then A plus B plus C, A plus B plus C, again A plus B plus C, and then A plus B plus C. So that will be the elements in the first row, and then B, C, C, A, and A, B. After this, we can take A, B, C common. So if we just take A, B, C common, so we'll get 1, 1, 1 here. So, sorry. So we take A plus B plus C common here, we get 1, 1, 1. Now, the moment we get 1, 1, 1 in any row or the column, after that, pretty much a very standard thing that we have to do, right? So what do we do after this? Simple. Keep the first column as it is. Second column, so C2 minus C1. And the third column, C3 minus C1. Obviously, because we want to create zeros. So A plus B plus C here, and then 1 B C, 1 B C, and then 1 minus 0, C minus B, A minus C, then again 0, A minus B, and B minus. A minus B minus A, C minus B, A minus B, C minus B, A minus C, A minus B, and B minus C. Okay. Right. So B minus C. After this, we just expand from this element, and I think we'll get what we want. So A plus B plus C, we expand. After this, we get C minus B into B minus C minus A minus B into A minus. So if we just expand this, we'll get what is required. It is just expanding after this, simple expand. So after this, we just expand and we'll get this. And from here to here, this is an identity, which we have already studied in our junior classes. So this is equal to 3ABC. Simply, this is an identity. So once we prove this, we will be able to just comment on that. We'll be able to just comment on that. Okay, the only thing is we'll get a negative outside. So AB plus EA, yeah. So our identity, I just recall of the identity, A plus B, A cube plus B cube plus C cube minus 3ABC is equal to A plus B plus C into A squared plus B squared plus C squared minus AB minus BC minus CA. So if you just see here what we are getting, let's just expand and then we can go ahead. So BC minus C squared minus B squared, and then this is A squared minus AC minus AB, and then so minus A squared plus AC plus AB, right? So if you just see what this is, so this is what we are getting here. AB plus BC plus CA minus A square, B square, C square. And if we compare this to this identity, it is negative of this. So negative of this will be 3abc minus a cube minus b cube minus, right? So this part is not so important. The important part here we have to remember. So after doing this, it is better to remember this as a result. So if we get a circular elements in our determinant, this is always the result. So, and the process also, we should be clear. Just be very aware if the if the rows, elements of the rows sum to same or elements of the column sum to same. Just we always start with that. Take that column, have 1, 1, 1. Once we have 1, 1, 1, then create zeros. All right. Thank you.